Hey class, welcome to lesson 2.2, your virtual algebra lesson. This is about angle relations. There's 4 objectives in these next couple lessons. You are going to learn how to identify and find the measures of supplementary angles, to identify and find the measures of complementary angles, to find the measures of vertical angles, to explore angle relationships for 2 parallel lines cut by a transversal. Some of those words might be new to you, but we'll get to those. So you should eventually learn those. We're going to start with a little bit of a review. You should pause the video anytime you feel like you can maybe do some of the problems, and then you can just check back with the video to see if your answers are okay. A couple of important things to know about triangles, and this is probably a review, but the sum of the measures of the interior angles of a triangle is 180. That means this angle plus this angle plus this angle add up to 180. If you ask me in class, I'll prove to you that that's true. So the equation you can write to represent that this triangle would be angle A plus angle B plus angle C is equal to 180. Notice the little angle symbol I've been using. You'll see that more. We can just shorten that to A plus B plus C, just knowing that each of those are angles equals 180. Right angles measure 90 degrees. The measure of an acute angle is less than 90 degrees. The measure of an obtuse angle is greater than 90, but less than 180 degrees. Complementary angles are 2 angles that where their measure sums to 90 degrees. So it's a pair of angles that add up to 90. And supplementary angles are a pair of angles that add up to 180. Go ahead and pause the video now and see if you can complete the following using the right triangle. Right. Notice this symbol right here. That is the symbol for a right angle. If you pause now and then resume, you can catch these answers after you've filled in the blanks. Angle A is a right angle. Angles B and C are acute angles. They are also complementary angles. Because remember, all 3 angles add up to 180. And so if we take 180 minus the 90 degree angle, that's the right angle right here, we're left with 90 degrees for angles B and C. So that means they're complementary. And the measure of angle B equals 90 minus C. We could just say 90 minus C for that one if we wanted to. We call this C and that 90 minus C. Somewhere in earlier grades you explored vertical angles. In each drawing below, angle A and angle B are vertical angles. Do you see another pair of vertical angles in each of the figures above? Again, pause at any time if you want to write down an answer ahead of time and then come back and check. You probably said that those 2 angles marked in red are vertical angles also, and so are those 2. In these drawings, angle A and angle B are not vertical angles. In drawing 1, A and B are adjacent angles. And this one, A and B, are not vertical angles because they're not created by the intersection of two lines. And in this drawing, angle A and angle B are not vertical angles because, again, they're not the intersection of two lines. So when two lines intersect, two angles that are opposite one another are vertical angles. You may have noticed that vertical angles are equal as well. And here we're wondering, how can we prove this conjecture that we think they're equal? I'm going to let you think about that, and if you can come up with a way, I'll give you a pop sticker on Monday. If you can show to the class that without any doubt, vertical angles are equal. When two lines intersect, two angles that are opposite one another are vertical angles. So that's the first blank. And I'm going to use that little symbol there for angles. Vertical angles are, go ahead and pause the video here if you want to see if you can get the answers first. Maybe do them in pencil so you can erase them if you have to. But vertical angles are always equal. Vertical angles are sometimes right angles, and vertical angles never have a side in common. They're always opposite each other. Remember, now I'm just going to do some problems that I think will help you get started on doing these, and then the ones that I skip we'll do in class tomorrow or on Monday, depending on when you watch this video. So I'm going to do this first problem right here, number 1. And if you look closely at these two, at this figure, this angle and this angle are vertical angles. And since they're vertical angles, we can determine their measure without a protractor. We know that these two angles together make up one of the parts of the vertical angle, so T plus 80 is the measure, and that's equal to the measure of the other vertical angle, which is 105. And then to solve that, I'll just backtrack and do 105 minus 80, and that equals 25. So T is 25. All right. Number 2 we're going to do in class. And number 3, we'll do that in class also. All right, here's a new definition. We covered this earlier, but supplementary angles are two angles that add up to 180 degrees. And here you can see they use the measure of angle 1 plus the measure of angle 2 equals 180. Supplementary angles don't have to be adjacent angles. Like in the first example, they can be separated. And these two, if we slid the one angle onto the other, you notice that they make a straight line, which is 180 degrees. Complementary angles are two angles that add up to 90 degrees. 1 and 2, we know those are 90 degrees because of this side being a right angle, so that means this side is also a right angle, and a right angle is 90 degrees, so those two angles together make 90 degrees. All right? We're going to do number 5 here. So I'm going to make a copy of that and make it a little bigger so I can explain more. All right, here's number 5. We want to find the measures of all of these angles. Angle A, angle B, angle C, angle D, and angle E. And we're going to use some of the ideas we just talked about supplementary angles, maybe complementary angles, vertical angles to help us out here. One thing that I noticed right away is that 120 and D are opposite each other, created by two intersecting lines, so that means they're vertical angles and they are equal. So D is equal to 120 degrees, angle D. We'll say measure of angle D so we get used to that notation. And now next you might notice that C and 120, if we combine those, they make a straight line, which is 180 degrees. So C plus 120 is equal to 180. So that means C equals, by backtracking, 180 minus 120, which is 60. So the measure of angle C is 60 degrees. Now, you probably noticed that C is equal to B, since they're vertical angles. And so we know that C is 60 degrees, so B must also be 60 degrees. They're vertical angles. You may have noticed here that angle A and this angle next to it make a straight line, so they add up to 180. So A plus 135 is equal to 180. By backtracking, we get A equals 180 minus 135, which is 45. So the measure of angle A equals 45. And now we can find the last missing angle, which is angle D, or angle E. We know that angle D is 120. We know that angle A is 45. So we have E plus 120 plus 145. Those are all of the angles inside of the triangle. We know that they have to add up to 180. So by backtracking, we get E equals 180 minus 120 minus 45, which equals 50. So the measure of angle E equals 50. The next problem we're going to do is problem number 8. It says two angles are complementary. If you know one angle is twice the size of the other, you can determine the measures of the two angles. If so, what are the measurements? I think we can determine that. If they're complementary, then if we draw in the two angles, they're going to form a right angle because complementary angles add up to 90 degrees. So one of the angles is smaller than the other. In fact, it says that one angle is twice the size of the other. Let's just call one angle X. So the measure of this angle is X. That means the measure of this angle is twice as big as that, so we can call it 2 times X. So now, together we have 2X plus X has to equal 90 degrees. And 2X plus X, those are like terms. We can combine them and make them 3X equals 90. And then by backtracking, we get X is equal to 90 divided by 3, which is 30. And if X equals 30, then 2 times X equals 2 times 30, which is 60. So this angle is 30 degrees, and this angle is twice as big at 60 degrees. And together, the two angles add up to 90 degrees. I'm going to have to end the recording here because my time is running up, but there's going to be a second part to this video that you need to watch. You can see that on the website.